CIN. We've been using CIN. So we can scroll past this. To use CIN, it requires the IO stream file. What's it used for? To read input from the keyboard. There are other kinds of IO streams. You can read from a file as easily as you can read from the keyboard. If you're going to get information out of it, you use greater than, greater than. So CIN, greater than, then variable name. Input is stored in one or more variables. Now that's something we hadn't done, did not do yet, is to store input from CIN that was all entered on the same line into more than one variable. But not too hard to do that. I think we're on Lecture G. Go and grab the new improved boilerplate with use math defined so we can get pi and things like that out of it. Okay, so here we go. What if we wanted to read in 3 pieces of data at the same time, like a first name, a last name, and a middle name? We could ask them to type that in. Cout less than, enter first, middle, and last names, or name, right? Like that. Space greater than, end quote, semicolon. Now we need a place to store that data. So string first, comma, middle, comma, last. So what we can do is, in a single CIN statement, say CIN greater than first, greater than middle, greater than last. Now there's some reasons I don't really like to do it that way, but it does work. And just to show that it works, let's change the cout statement to say hello there, end quote, less than first, less than ENDL, just so that we'll see some kind of message pop up after they've typed their data in. Okay, so enter first, middle, and last name. Joe, Jim, Bob, right? That's his name, Joe, Jim, Bob. And it says, hello there, Joe. So it seemed to work. Now here's why I don't particularly like doing it that way. If I goof up, like if I just type in Joe Bob, I don't get any indication what's wrong. And it just hangs there, waiting for me to do something. I start hitting enter. I start hitting escape, right? Finally I type a bad word and hit enter, and then it's done. So what is it doing? Why did it do that? Because it's waiting. It filled in the first name with Joe. It filled in the last name, the middle name with Bob, and then nothing ever went into last. And so it was sitting there waiting for us to enter something to fill in the last. That's why I don't particularly like to do it that way. But it works. It absolutely does work. First thing you type gets put in there, the middle thing you type gets put in there, the last thing you type gets put in there. So if I ran it again and just typed in one thing per line, that's legal, right? Thomas, quote, let's pretend his middle name is Blaine, don't know what it is, and then Jefferson, right? It worked. There I get my first, middle, and last name. Didn't matter whether I typed it all on one line, whether I typed it in 3 different lines. It's doing what's known as tokenizing. Tokenizing is when it's scanning the input for things separated by spaces or character turns. So when I typed in Thomas, hit enter, it knew that the enter key marked the end of the first piece of input, so it stored it into first. Then it was waiting for me to give it a second piece of data. And if I kept hitting the enter key, it never would have filled it in. I finally had to type in something, so I typed in Blaine and hit enter. It accepted that, stored it in the middle. Then it's still waiting for the third thing to be entered, which is why it went down to the third line. And I could have hit space, 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 whatever. And when I finally typed Jefferson, then and only then did it fill in last. Here their example is entering the length and the width. They do it in two separate steps, the length and the width. They also could have done it in one step. And I've already told you why I don't like doing that, because if they only type in one piece of data, they don't know what they're supposed to do next when it's just sitting there waiting for them to type in a second piece of data. And here's their example of it. Nope, the CIN does convert data to the type that matches the variable. Unlike Python, where if you use input, it comes in as a string and then you have to convert it to an int or a float, CIN will convert it into whatever the data type is. If height is declared as an int, it stores it as an int. That can kind of get you into trouble. What if the user types in the wrong thing? What if we declare a variable as an int and then let them type in, or they type in a decimal point even when we didn't want them for a word, right? Cout less than, enter age. Space greater than, end quote. Now we need an age variable, int age, and then CIN greater than age. Looks good. It'll work. Bob, Bob, Bob. I'm going to wind up copying out those things pretty soon. Enter the age, 40, 50, whatever. It works. Great. What if I make a mistake? What if I type in 50.5? Bob, Bob, Bob. 50.5. Well, we don't see what's wrong, but there is something wrong. We could print out the age and find out what it really was. Even worse, what happens if I type in a string for where it wanted my name? Bob, 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 Bob. It's not doing as badly as I expected. I expected it to go into an infinite loop trying to enter data. Let's print out their age, though, and see what their age equals after that happens. Right. So hello there, and then cout less than, your age is space, end quote, less than age. So if we type in garbage data, let's see what it looks like. So I'm going to type in Bob, 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 right there. Alrighty, you see that? It's corrupted. It's total garbage. That's not too cool. There are ways around that, but we're not going to learn them yet. What if we typed in a number, a fractional number, like 0.5? Bob, 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 0.5. It says your age is 0, so it lost the 0.5. That's not too bad. What if I typed in 40.5? Let's see if it at least keeps the 40. Bob, 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 40.5. Yeah, okay, so that's not too bad. Displaying a prompt. The fact that you send something to cout and then you read from CIN is called prompting the user. How tall is the room? Let them type it in. You should use cout to display a prompt before each CIN statement. Very true. That's why I don't like that business where you read in 3 things at once. I'd rather see a message before everything they type in, under most circumstances. And here's their example of it, entering the height and the width. Whatever they type in must be separated by spaces or carriage return. The order is important. The first thing they type goes into that one. The second thing they type goes in there. Math expressions. Math expressions, arithmetic works pretty much the way we expect with one key difference, which is division. So firstly, let's just go into the fact that we know what multiplication is, we know what division is, we know what parentheses do. We've been doing math for a long time, so we know how to handle that stuff. But what we need to remember, the order of operations. multiplication happens before an addition and a subtraction. If you type 2 plus 2 times 2 minus 2 in a scientific calculator, anything better than the $5 calculator you buy at Dollar General, it's going to do this part first. Multiplications happen first, so it's going to take this and do 2 times 2, which is 4. 2 plus 4 is 6, minus 2 brings it back down to 4. So the order of operations, well, this doesn't list them all. Too bad it doesn't. Guess we're going to put it in here. You may remember the expression PEMDAS. Please excuse my dear, I didn't make this up, Aunt Sally. What does it mean? P is for the parentheses, MD is for multiplication and division, and also modulus. And then addition and subtraction. Right, so that's what the letters in that acronym mean. Mnemonic, excuse me. I believe that's the correct term for it. So anytime you have an expression, like if you had A is equal to 2 plus 3 times 4 plus 5, you have to figure out, or the computer has to figure out what order they're going to be done in.
It's PEMDAS, correct?
Yes, it is, but we don't have an exponent operator, so I left it off. You're absolutely correct. That's where the excuse comes from, right? And I spelled that wrong, right? Well, we don't have an exponent operator, unlike Python, so we can't put star star there. So this expression is dumb. So why don't I delete it? Please remember, though, PEMDAS. What do we do first here? We do the parentheses first because that's the top of the hierarchy, top of the order of operations. So we would add 4 plus 5 and get 9. Then what do we do? Next is multiplications. So we would multiply 3 by 9 and get 27. Then and only then could we add the 2 to it to get 29. And you can get different answers based on the order in which you do these things. Not coming up with a great example of that right now. One thing to notice is that just because M came before D in our little mnemonic doesn't mean that you do all the multiplications first and then the division. Or for the adding and the subtracting, you don't go through and do all the additions before you do the subtracting. So like if you do this, A is equal to 2 plus 10 minus 8. I think I did that wrong. Plus 2. All right, so how should we do it? Well, since everything is an addition and a subtraction, we should just do them left to right. It's called left to right associativity. They're all at the same level, so 2 plus 10 is 12, minus 8 is 4, plus 2 is, right, 6. But what if we had mistakenly thought that since the A came before the S, we had to do all the additions first? In that case, we go 12, all righty, and then that's a 10, and then a 12 minus 10 is a 2. Totally wrong answer. Same for multiplication and division and modulus. It's not that they have to be done in this order, it's that they're all in the same category. And then once you're resolving all of them in the same category, you just do them left to right. So here's a little worksheet that we could use to fill out, and unfortunately the answers are right there. Quick slide it off. There we go. So what gets done first? Multiplication. 2 times 4 is 8. Add 5 to it, 13. What gets done here first? The division or the subtraction?
Division.
Yep, so 10 divided by 2 is 5, minus 3 is 2. Here the multiplication is going to get done first. 12 times 2 is 24, so 8 plus 24 minus 4, whatever that is. Good old modulus. Modulus is the odd one. That means remainder of. There's something I need to talk about with regard to division and modulus. I'll get to that, but that would be the first thing that would happen. And 17 modulus 2 is 1 for reasons I will explain if you don't already know them. So what is modulus? Well, first let's talk about integer math. If you're doing something like this, let's pretend that you only have 2 times 4 now. If they're both integers, the result is an integer. If you do 2 times 4, well, 2 is an int, 4 is an int, so the result's going to be an int. But if one of them is a float, like 2 times 4.5, We can't do math, so the computer can't do math on disparate types. They have to be of the same type. That doesn't mean we have to program them to be of the same type. The compiler provides the fix for them to be of the same type. And it takes the less accurate version, the less precise version, the one that's low on the hierarchy of conversions, and converts it to be the one of the more accurate. So if we were going to list our conversion hierarchy that it will do, it would look something like this. The bottom are ints. Above that are floats. Above that are doubles. And I skip long longs. It's like that. Ints will be converted automatically to long long. Long longs won't get converted to ints. Floats will get converted to double if need be. Ints will get converted to float if need be. If both operands, what are operands? Operands are the things on either side of the operator. So if we have 3 plus 4, plus is the operator, 3 and 4 are operands. If both operands of a math operator, an arithmetic operator, this is a binary operator, by the way, binary meaning it takes 2 operands. If both operands of a binary arithmetic operator are ints, the result is an int. As long as they're of the same type, great. If they're both long longs, then the result is a long long. If they're both doubles, the result is a double. But if they are of mixed types, the lesser type is promoted to the greater type. So if I do this, 3 plus 4.5, computer can't add an int to a float. Sounds weird, but it can. So what does it do? It turns this one into a float so that it can do the math. And then the answer to that would be 7.5. The int would be promoted to the float. I seem to have missed a word here. Hope that makes sense. What if you need to convert from a higher order type to a lower order type? You use casting. What if you have a float and you really do want it to be in an int? Well, if you have a float and you really do want to put it into an int, let's say that I declared a variable called d, put 10.10 in it, and then I said int I is equal to d. C++ will usually compile that, but it might flash a warning. Might give us a warning. The way to get it to stop displaying the warning is to say, I want you to convert to a double. That's the Python syntax. There's 3 different syntaxes, at least, that C++ accepts. But you've seen that one if you've taken the Python language, except that word would have been float. But it's not right. I totally goofed on that one. I'm so sorry. Since I want to turn that d into an int, I would use the int function to do that. The more common way to see it is to do this. I is equal to, and you'll see this in a lot of languages. C, C#, Java, like that. What does it mean? It takes D and so-called casts it into int. What does casting mean? Like if you have a bunch of metal and you want to form it in the shape of, a crescent wrench or whatever, you have a cast of that wrench. You pour the metal into it and it forms the shape, right? So it's reshaping it. We are reshaping the bits here into the form of an int. Now that's a problem, isn't it? Because it's got this decimal place. That's going to get lost, yeah. But we're accepting that. We're telling the compiler, yeah, it's okay to go ahead and do that. We understand that you may lose some data. That if the result of this is larger than 2 billion, there's going to be overflow, and if there's a decimal point, it's going to be lost. That's what casting is. This is the second syntax. There's that Python syntax, there's that C-style syntax, and then there's one more, which looks goofy. Static underscore cast less than int greater than parentheses. This is a lot of typing. D greater than, like, that's the C++. That's the official C++ way of doing it. It's a recommended way of doing it. And honestly, that's a lot of typing, and if I was in a hurry, I'd just do it like that. If you feel like doing it like that because you took Python and you think that's cool, go ahead and do it that way. So these are 3 different examples of casting. If you're promoting data from a lesser type to a greater type, you don't have to cast. The compiler has no problem at all taking an integer and storing it into a float or a long or a double, right? Because the int is small, and it'll store in any of those points without the threat of data loss. If you're going the other way, if you're going down the chart, if you have a double and you want to store it into a float, go ahead and cast it. And like I said, the C++ compiler will probably accept it if you do that anyways without casting it, but it may display a warning message. It's appropriate to go ahead and use the casting. In some compilers, it will not compile at all, and certainly when you go to some languages like Java, it flat out will not compile at all. If I had this, I is equal to D, in some compilers, in some languages, flat out would not compile because that's a double, that's an int. It would mark that as an error, and it would say possible data loss. And it is, because this can be larger than 2 billion, and it can have decimal points, and all of that would be lost when stored into an int. So why was I talking about mixed types? Now I remember. An int divided by an int results in an int. Makes sense, right? 8 divided by 4, what's that? That's 2. 6 divided by 3, that's 2. What's 5 divided by 3? Well, an int divided by an int is an int. So it's not going to be 1.6666666. It's just going to round it down. The result is an int. It truncates the decimal point, so it's not 1.666. It's just 1. What if you have 1 over 3? It's not 0.333. Since both of these are integers, the result is an integer. 0.333 truncated, rounded down, is just 0. That'll mess you up. The surface area of a sphere, or the volume of a sphere, I don't remember which volume, is 4/3 pi r cubed. So if I typed in 4 divided by 3 times pi times r, what is that? 4 divided by 3, they're both integers, it's going to round down. It's going to say 1 times pi times r cubed. Uncool, right? Because it just messed up our formula. What about if you're converting to Celsius? The way to convert to Celsius is to either divide by 1.8 or multiply by 5 over 9. Okay, so if we took our Fahrenheit and we multiplied it by 5 over 9, well, what is 5 over 9? They're both integers, rounds down to 0. So every temperature in Celsius is 0? Nah, it's not cool. Well, how do you fix that? You just make sure that one or both of them are not integers, right? That would fix it, because then the 9 gets promoted to a float, and a float divided by a float is a float. No problem at all. Now it would do the math just fine. Just like that 4/3 business I said, where you have 4/3 pi r squared. If either the 4 or the 3 had a decimal point after it, and why not do both, then it would work properly. Then the equation could function correctly. So avoid integer math, avoid integer division by making one or both operands floating point. All right, so say we were back to this example, 5 divided by 3, or 4 divided by 3. That's what? That's 1. But how many was left over? What was our remainder? Well, 3 goes into 4 one time with a remainder of, is anybody listening who can fill in the last phrase? 3 goes into 4 one time with a remainder of, what's left over after the 3 goes into the 4? 1. Yeah, so 4 modulus 3 is equal to 1. 4 divided by 3, take the remainder as 1. How about 5 divided by 3? 5 divided by 3 is still 1. 5 modulus 3, well, when 3 went into 5, one time it had a remainder of 2. 6 modulus 3. If I could type. 6 modulus 3. 3 goes into 6 2 times, but it's even, right? There's nothing left over. So, oh, that was supposed to be a divide. So 6 modulus 3, there was nothing left over. 3 went into 6 2 times with nothing left over. What if you have something strange like this? 10 modulus 15. How many times does 15 go into 10? Not even once. So what was left over? The 10. So 10 divided by 15 is 0, and then 10 modulus 15 is 10. Why do you care? Why would you ever want to use modulus? Well, there's one type of problem at which it excels, and that's if you're doing conversion from one unit to another unit and calculating what is left over. What do I mean by that? Let's go back up to here, and I want to convert a number of pennies to quarters and pennies, or quarters and cents. So pennies is equal to, I don't know, 3, 4, 5, 6. That's how many pennies I got. I'm going to make them an int. So int quarters is equal to 3, 4, 5, 6 mod divided by 25, right? Let's just make this 102, right? It'll be easier to spot. And I did not mean to type that number in again. So, you know from personal experience that there's 4 quarters in a dollar. So when we divide our number of pennies by 25, we're going to get 4. And it's integer mass, so it's not going to be 4.00 whatever. It's just going to be flat out 4. And now we want to know what's left. The cents involved is equal to the quarters, the pennies modulus 25. Once you take your 4 quarters away, how many cents are left?
2.
Yeah, 2. So this is equal to 4, and this is equal to 2. And if we write that out, C out less than pennies less than quote space pennies equals end quote semicolon, and then C out less than quarters less than quote quarters and end quote semicolon. This is a long output. C out less than cents less than quote space cents period / n end quote. And why did I type all that? Because I want it to look like this when it runs. And I'm getting really tired of typing in Bob something, so I'm going to go and comment that stuff out. Right, so anyways, 102 pennies equals 4 quarters and 2 cents. So it worked. It converted from one format to another. How about pounds, tons into pounds, or yards into feet? Yeah, let's do yards into feet. And I do want to go and comment out this stuff about inputting stuff. So I'm just going to put // in front of all 6 of these statements. 7 if I count the blank line. Tired of typing that in. Let's calculate yards now. So if we have $400 feet, let's say we have 1,000 feet. Yards equals 1,000. No, wait, feet equals 1,000. So int feet equals 1,000. We want to calculate the number of yards. Well, it's just feet divided by 3, right? If it's a 300-foot field, 300 divided by 3 is 100 yards. So int yards equals feet divided by 3, and we want to find out what's left over. So int ft equals feet modulus 3, like that. And then we could print it out again. And gosh, that was a lot of typing. I feel like just copying and pasting it and then changing all the feet and the yards and stuff. I may regret doing this, but let's see. So I'm going to say feet and feet on the first line, yards and yards on the second line. And I better stop and see how y'all are doing. And then feet on the third line. You may ask why I created a new variable rather than just not reuse feet again, right? Because I could have said feet equals feet modulus 3. If I did that, I would lose the original value. I wouldn't be able to print out that we were trying to handle 100 feet. Just like up here, why did I do pennies and cents? Because if I'd made this say pennies equals pennies modulus 25, I would have gotten the right answer, but I wouldn't be able to print out the original number of pennies. This 102 would be lost, right? So that's why I create 2 variables like that. let's run it and find out how many yards and feet 100 feet really is. I guess we won't because there's a syntax error. Let's go find them. First is undeclared, age is undeclared. Okay, I had more I needed to comment out than what I expected. Yuck. Comment out those things too. Comment the line that says hello there first and your age is, if you're typing this in. All right, so 100 feet equals 33 yards and 1 foot. That sounds right, because 100 feet, 33 yards is 99 feet, and there's 1 left over. So you can use modulus to calculate the remainder when you're doing that kind of conversion. Some languages will support modulus using floating point. Like if you want to turn something centimeters into inches, so you're going to divide by whatever that factor is, or you're going to convert inches to centimeters, so you divide by 2.54, and then you need a modulus by 2.54. It doesn't work in this particular language. Modulus in this language only works with integers. Algebraic expressions. If you look up a formula and it says area equals LW, we can't type it in to our program like that. That's fine for math books. It's not fine for us. Why? Because it doesn't know what LW is. It thinks LW is a variable. It doesn't know that there's supposed to be a multiplication symbol between them. For some reason in books it's cool to leave the multiplication symbol out, but it's not cool in programming. We'd have to put that asterisk there or it's not going to work. So for example, the formula for calculating interest looks like this. If we were going to get this to work, we couldn't just type in NT when it was that part of the expression. We'd have to make it N times T. We'd have to actually put the asterisk there. Let's go ahead and write this one up, because there's a couple subtleties that are involved. For one thing, this NT here, what am I going to have to do to get that to work? Well, let's start typing in. I'd like to leave that on the screen so I can possibly see it. But down here, before the system pause, let's just create some variables, and I'm going to make them all doubles so that we don't have any integer division that'll mess us up. So double P, which is the principal, equals, let's just start off at $1,000. That's the starting amount. That's the principal. And then R is the interest rate. So double R equals, let's say we get 10% interest, so 0.10. Be pretty nice. 30 years ago, you could get checking accounts that earned interest even, but nowadays, like the Fed sets the interest rate so low that banks would absolutely not do that. So there we go. What's next? We need R. Wait, we've got R. We need N. What is N? N is the number of times it is compounded. Now, I asked the last class, and one of the students who actually knew something about it, which I didn't, said that the most common thing is to compound it once per year. Not 12 times a year like I kind of thought. So it's 1 time per year. So I'm going to set N equals to 1. Double N equals to 1, and I'm going to add a comment. 1 time per year. And then one last variable, T. What is T? It's the number of years. Double T equals 10 years. Let's do 1 year first, because that'll be easy to figure out, right? 10% interest of 1,000 should be $100. Okay, now that we know all this stuff, and we could declare this last variable A on its own line so that we can add a comment. Double A, that's the final amount of the interest. Now let's calculate it using that formula. A equals P, parentheses, and I'm doing this wrong, plus 1 plus r divided by n. I'm typing in it exactly as I see it. And now, since there's no exponent thing, we're kind of up a creek. I can't type that like I can in Python. Wish I could. I can't type the upward caret and pretend it means exponent. Wish I could. So instead, we're going to have to use math.pow. So math.pow. Excuse me, it's just POW in this language. It's not math.pow. As long as you've included the CMath file or you're using Windows, you have POW available to you. And so there's that, and then there's NT. That's our formula. Whoops. Where'd that come from? But it's not right. I've already totally goofed it anyways. Why did I goof it? Because the only thing you're taking to the exponent is the 1 plus the Rn, and I took everything to the exponent. So I'm going to fix that. I'm going to make that say POW, and I'm going to make this say P. All right, well, we're seeing already, right? There should have been a multiply symbol there. So I'm going to go ahead and put the asterisk there. No instance of overloaded function POW. That's true. I need to put a comma here. So R divided by N, comma, NT, right? Because that's the power we're raising it to. Now, why is it underlining NT? NT's right there, right? We've got NT right there. We have a variable named N. We have a variable T, so why is it counting that as an error?
With the multiplication.
Right, because there is no variable called NT. It doesn't just assume that you're going to multiply things together. You have to actually put it there. Now, how would we calculate interest earned? Interest earned is the beginning principal minus the final amount. So why not calculate that too? Double earned equals the initial value, which was P, minus A. And now let's print out some useful information about it. We really should echo all this output back. We should say starting principal 1,000, interest rate 10, 1 time per year, 1 year. We should print all that information so that the user knows where all this is coming from. So C out less than starting principal equals end quote less than P less than ENDL. Right? And I'm just going to go down these variables and do that. C out less than interest rate equals end quote less than R less than ENDL. This is called echoing the input. If the user typed in all this stuff, they like seeing it back in their output, right? Like when you enter your address and you've chosen all your items you're going to buy from Amazon, you like to see that screen that says, you know, press OK to buy all this stuff, you know, and press OK to choose this email address or this address. You don't just want it to automatically be purchasing everything that you click OK. You like to have that final screen so that you can check to make sure that all the data is correct. Same thing here. So C out less than times per year equals end quote less than N less than ENDL. Getting close to being done. We just have to do interest earned and the final result in the top in the years. C out less than years equals end quote less than T less than ENDL. I know it's tedious, but this is going to be part of your homework, so I don't mind making it a little bit complicated. Don't sweat if you haven't typed it all in, because of course these are going to be in your notes. Now let's go ahead and print out the interest earned and the final amount. So C out less than interest earned equals end quote less than earned less than ENDL. Now we could have chosen better variable names, right? Instead of R, it would have been nice to say rate. Instead of N, we could have said, you know, times per year or something like that, or interval or something. Instead of t, we could have used years. But I was doing that formula exactly, so I reverted to going back to single letter variable names. I could modify this to have better variable names now, or once I have it working, I might do that. So interest earned is that, and now we're going to print the total, A. C out less than total after interest equals, end quote, less than A less than E and DL. All right, I hope it works, because that was a lot of typing. All right, so $1,000, interest rate is 0.1, one time a year for 1 year. Interest earned is $100, but I did my subtraction wrong. Right, it says minus 100. I need to fix that. I need to reverse these two amounts, because A is the final amount. See, if I'd chosen a good variable name, then I would have known that. So I'm going to make that A minus P. I need to correct that line. Just edited that line, run it again. Right? Interest earned is $100, total after interest is $1,100. Wouldn't it be prettier if we had a dollar sign involved? I'm going to put a dollar sign right here, and I'm going to put a dollar sign here. No, not after years and times per year. That's dumb. But for starting principal, it's nice to do that. For interest earned, it's nice to have a dollar sign. For total after interest, there's got to be a better term for that. All right, now it's starting to look really good. All right, I'm liking it the way. I'm liking this. All righty. So, like I said, these are lousy variable names. Single letter variable names should be avoided. What does R mean? It means rate. But if I change it, I'm going to have to change it there, there, and there. Why not? I'm going to make this say rate. I'm changing that line. I'm going to make this say rate. I'm changing that line. And I'm going to make this say rate. Changing that line. And since that A got me, I'm going to change that one. So instead of being A, I'm going to make it say final. No, that's a bad word. No, it seemed to not be a bad word. For a minute it was lighting up as blue, so I was afraid it was a keyword. It is in Java. And so I'm changing S line. I change final. I'm changing the equation. I'm making a lot of changes. I will walk around and help. And then the double earned is A minus final minus P. And that leaves me with something else I gotta fix. Where down here it said A, I need to change that to final. So there were actually 4 lines I had to change there. Probably weren't able to keep up with all that. My fault. Let's make sure it still compiles and runs. I could change the other variables, right? Like the years variable. It is still working. What if it was compounded monthly? 12 times a year. I'm going to change this in to 12 and just run it again. So compounded monthly, we earned a little bit more interest, whole $4. Changing it back to 1. But since T means years, I'm going to take that T and I'm going to change it to years, and I need to fix it there. And notice that it underlines what needs to be fixed. I need to fix it there. It's broken there too. I need to fix it there. See, now the equation and the output and the variables tend to make a lot more sense. They're not just single letter variable names. I didn't change P. I could change it to principal, right? And N, I could change to times per year. But I've done a good job at it, I think. You know, I got 80% of them done with good variable names. Yeah, there we go. All right, if I was going to veer off and work on something else, we would make an interest object. where we had a class that contained all this information, and we would stick this into a method. And I would like to do that, but I would not like to do that this time. We will save that, because since we're going to be doing homework on this portion of it, I don't want to make this portion of it so complicated that when it's time to do the homework, then, you know, it breaks your brain. So for example, if you have m is equal to y2 minus y1 over x2 minus x1, you better group these parts in parentheses, right, to get them to be done in the correct order. If you don't group y2 minus y1, here's how it would be if it was absolutely wrong. M equals y2 minus y1 divided by x2 minus x1. Is that anywhere even close to being correct? Not at all. Why? Because it would do that first. Just ain't right at all. So we need to put that in parentheses. We need to put that in parentheses. That's shown over there. So 6b, make it 6 times b. I love saying times. It sounds so childish, but it's easy to say, right? 312, sure, 3 asterisk 12. 4xy, 4 times x times y. When you mix apples with oranges, type conversion. Now fortunately, I've already spent 20 minutes typing about that. Operations are performed between operands of the same data type. X equals y times z. If y times z, if both of those are ints, the result's going to be an int. If one of them is a float, it's a higher order data type, so when y times z happens, the result is going to be a float. If they're not of the same type, if both operands are not of the same type, C++ will convert one to be the type of the other. It can't actually impact the results of calculations. So higher order. I gave you a little chart, but this is the bigger one. Ints can be promoted to unsigned ints, although if it's negative, I don't know what happens. Unsigned ints can be converted to longs. Longs can be converted to unsigned longs because they're a little bit bigger. Why? Because the signed bit takes up a piece of data, so if an int can go up to 2 billion, then an unsigned int can go to 4 billion. It just can't hold any negative numbers. A long can be stored into a float can be stored into a double, and there's really no such thing as a long double.
I don't think it's a long listed.
Yeah. This slide is junk. I would take long double off, and I would make that long, right? And then that unsigned long, which sounds absurd. Here's the ones I really want you to remember. Ints go to longs go to floats, and floats go to doubles. That's what I like for you to see. It's always safe to go from an int to a long, because longs hold integer data, but much larger versions. It's always safe to go from a long to a float. A float can hold a long perfectly. I say that, I can think of perhaps an exception when it would not, but I'm going to leave that exception alone. So type coercion. Sounds bad. I'm coercing it. That's an automatic conversion of an operand to another data type. Promotion is when it's being converted to a higher type, and that's always safe. Demotion is when it's being promoted to a lower type, like when you do with a cast. That's not safe. But when you cast it, you're telling the compiler, okay, I accept the risks. I know that the values are going to be okay. It's my fault if any data is lost. So coercion rules. Small data types like chars and shorts and unsigned short get promoted to ints. If for some reason you wanted to multiply a character by an int, you could do so. Like if you did this, character ch is equal to capital A, end quote. Except since it's a char, it has to be surrounded by apostrophes, not double quotes. And then you wanted to C out less than 2 times ch, less than EDL. Well, what's that going to equal? Well, we've done the ASCII chart business, right? We went to ASCIItable.com and looked up values and stuff like that. Is that a yes or a no?
Mm-hmm.
Yeah, we did. And the A is a 65. And so 2 times A is a 130. So when it prints this out, we're going to see it print out the number 230. Excuse me, 130, right? 2 times 65 is 130, and if I said 230, I was an idiot. Here we go. So that CH was of a different type than this. It got promoted to be an int so that the multiplication could happen. the char gets promoted to an int. Overflow and underflow. Overflow is when the data gets too large. It wraps around. I'm pretty sure that I showed you the Pac-Man example. Right? Did I show you all this? Yep. Why did that happen? Because the level counter was stored in 1 byte. The maximum value that a byte can hold is 255. So when it went to 256, it broke the program. Data was overwritten. So we could prove that to ourselves by like doubling a number over and over and over and watching when it fails. Let's write that, and it'll be the last thing we do today. So let's start our number off at 1, and we're just going to double it each time. So int x equals 1. Hope I haven't defined x already. And I'm going to use a for loop. Not that we've talked about for loops yet, so this is something brand new. But just to demonstrate the purpose, for x equals 1, starting at 1, and keep going while x is less than or equal to 30. So int x equals 1, semicolon. X less than equal 30, semicolon. X plus plus. That will count from 1 to 30. Just like the range statement in Python. A little bit different though, because since this is less than or equal, it will actually hit 30 rather than stopping 1 short like it would do in Python. Now let's multiply x by 2. X equals x times 2, and let's write it out. And by the way, this is real dumb. I already have a counter called x, and then I reused x.
The 4 ghosts in Pac-Man seem to have their own rules about how to pursue the player. Because of this, they rarely...
Cool. Alrighty. So I should not have called this x. That needs to be something else, like y or I or anything. So I'm changing every variable here. So let's see out the counter, right? See out y, followed by a space, followed by the value of x, followed by ENDL. And so we're going to double it 30 times and see if that breaks the data. Nope, it got to 1 billion. However, when we double it again, it might work, but if we doubled it 2 times, it's not going to. So my prediction is going to be that it'll break when it hits 32 or when it goes past 32. I mean, just to make sure, I'm going to make it 40 instead. Right, and so it doubled it 30 times, but the next time it tried to double it, it flipped to being negative, overflow. It was too much to hold in 4 bytes. So it corrupted it. And then after that, it's just 0 all the time. And I'm not sure why that happened, but you know, we exceeded the capacity of an int. What if we make it a long? Longs are twice as big, right? It ought to go for a long time if we do that. Let's see if 40 is enough to break a long. So I changed the data type from int x equals 1 to long x equals 1. Well, that didn't seem to make a bit of difference. What have I done wrong?
Well, in the chart it said long.
Long. Thank you.
Was
On Unix and on Mac, that would have worked. This compiler, nope. Thank you. Okay, so it got to 40 just fine. How about 60? Let's find out when it breaks. How many doubling we can do before the data becomes too large to be held in a long. Nope, 60 didn't do it. Am I going to make it 100 just to be desperate? Yep, I sure am. Here we go.
Please break.
There we go. It breaks at 63, right? It was able to double it 62 times, but then it exceeded the 8-byte limit for a long. If we made it unsigned, it would go a little bit bigger, but not much. So an unsigned long can hold a little bit more data because it can't hold negative, so the positive value is twice as high, but still not much, right? It got to 63, and then after that it was broke. That's data overflow. Data overflow is when the data exceeds, or the value exceeds the size of the variable. And as a reminder, ints and floats, bless you, are 4 bytes. Longs and doubles are 8 bytes. All right, so what's our homework going to be? Well, we went to the trouble of typing all this in. It's just going to be to make your program ask the user to fill in these values. Tell me what P is, tell me what R is, tell me what N is, and ask for the number of years. And don't make it dumb and just ask for P. Let the user know what P means, like what is your starting amount. And don't just ask them for N. Ask them how many times per year it is compounded, right? So they need to know what to type in. We're not writing this program for us, we're writing it for somebody else who might not know that N in that formula means number of times per year. So that's going to be the homework, to take the interest code we wrote, and I'll write this up all nice and pretty, right? And convert it into a program that asks the user for the values necessary, which were P, N, R, and T. But we changed their names. R became rate, T became years, and P and N were left untouched. If you feel like picking better names for those, so perform the calculations. You don't even need to change that code at all. Those calculations are already perfect. Display the results. You don't need to change that at all, right? Because the results are perfect. Should be, right? If we took $1,000 and compounded it for 1,000 years, I wonder how that would go. Well, I didn't get a chance to enter it, right? I would have to go up and modify my starting data and the times per year and the years equal to 1. So if I went back up here and found the years variable and changed it to 1,000, I'd get to perform my little experiment. A lot of interest, okay? So if I was going to live 1,000 years, I'd be rich. Okay, so that's enough. I think we've gone far enough. We do have a little bit of time after class when we end like 5 minutes early like we're doing today, so that I can answer questions about homework, but then I have to run off to the next class. So if you do have questions over homework, go ahead and hang out and we'll try to get to them, but if it doesn't work, we'll have to set up an office appointment, or we can type to each other in text.